What does it feel like to work on a complex AI product where it isn't just using a single machine learning algorithm to map from A to B, but that learning algorithm is part of a bigger, more complex project or product? I want to start off this week with two case studies of building complex AI products. First, building a smart speaker so that you can start to understand what it might feel like to maybe someday work on a complex AI product within your own company. Let's get started. Smart speakers and voice-activated devices like these are taking the world by storm. And if you don't already have one in your home, maybe you buy one someday. I'd like to go through a case study of how you would write AI software to get a smart speaker to respond to a verbal command, such as, "Hey device, tell me a joke." For this example, rather than using Alexa or OK Google or Hey Siri or Hello Baidu as the wake word or trigger word, to be more device agnostic, I'm just going to use Hey device as the trigger word or wake word to wake up, say, a smart speaker, and let's say you want it to tell you a joke. So how do you build a piece of AI software to understand a command like this and execute on it? These are the steps needed to process the command. There are going to be 4 steps. Step 1 is the trigger word or the wake word detection. The speaker uses a machine learning algorithm to input the audio clip and output. Did it just hear the wake word or the trigger word, hey device? So outputs 0 or 1. And once it hears the trigger word or wake word, once it hears hey device, it then has to perform step 2, which is speech recognition. So what the software has to do is take the audio of what came after hey device and map that to tell me a joke. This is also done with machine learning, whereas the first step here, use an A to B mapping to just tell it, did it hear the trigger word? This uses a different A to B mapping to map the audio to a text transcript of what you just said, which in this case is the 4 words, tell me a joke. Now, the algorithm has to figure out what you actually want by saying these 4 words. And so the third step is intent recognition. That means to take whatever you said and to figure out what you actually wanted to do. So today's smart speakers have a limited set of commands, such as they can tell a joke, or they can tell the time. So you can say, hey device, what time is it? They can play music. They can sometimes have you make a phone call. They can tell you what's the weather, like, hey device, what's the weather tomorrow? And so what intent recognition does is take the 4 words the speech recognition's output and use another piece of AI software, another A to B mapping that inputs those 4 words and outputs which of these 5 or other intents do you have. So in this implementation of a machine learning algorithm, the input A is the text transcript, tell me a joke, and the output B is which of these 5 types of commands did the user just utter. Of course, your smart speaker may be able to understand even more commands than just these 5, in which case B would be whichever of the 5 or 20 or 100 commands your smart speaker knows how to execute. No matter how you ask the smart speaker to tell you a joke, hopefully the intent recognition components will recognize your intent correctly. So that you can also say, not just, hey device, tell me a joke, but also, hey device, do you know any good jokes? Or, hey device, tell me something funny. Turns out there are a lot of ways for you to ask a smart speaker for a joke, and a well-designed intent recognition system should recognize most of them. Finally, now that your smart speaker has figured out that you really want to hear a joke, the last step is that there'll be a software engineer that has written a piece of code to randomly select a joke and to play the joke back through the speaker. In other words, to execute the joke. Just for the record, my favorite joke is, why are there so many shocking results in AI? Because AI is the new electricity. Shocking electricity, get it? Hope you enjoyed that. And so, all right, and in seriousness, you can think of the 4 steps of the algorithm as these 4 steps, where the first step is trigger word detection, second step, speech recognition, then intent recognition, and then finally, execution of whatever command the user asks the smart speaker to execute. So the process of having 4 steps in an AI system like this, or multiple steps, this is sometimes called an AI pipeline where you have multiple AI components. You actually have multiple machine learning components which process data one step after another. And it would not be unusual to have, say, 4 different teams in the company where each team focuses on one of the components of this AI pipeline. That's how we often organize projects within a large company. Let's now look at a more complex example. What if you issue a more complex command like, "Hey device, set timer for 10 minutes. These are the steps needed to process the command. First step, same as before, is trigger word detection. So input an audio and just let me know when someone said the trigger word, "Hey device." Then speech recognition, where you input the rest of the audio and transcribe the rest of the sound, the rest of the audio, set timer for 10 minutes. And now intent recognition has to input that text and output that your intent is that you want to set the timer. One difference between set timer for 10 minutes compared to the earlier example of tell me a joke is that you need to know how long to actually set the timer for. So in the execution step, you actually need to do 2 things. One is extract the duration. That means look at the text set timer for 10 minutes and pull out the phrase that tells you how long to actually set the timer for. And so if the user were to say, "Hey device, let me know when 10 minutes is up," then this extract duration step would have to pull out, again, the 10-minute phrase right there. And of course, there are lots of ways to ask for a 10-minute timer. You can also say, "Let me know when 10 minutes are up," or "Set alarm for 10 minutes from now." And hopefully the intent recognition and extract duration components will both be robust enough to recognize that all of these are different ways of asking for a 10-minute timer. And finally, to execute the command, there should be a specialized software component in the smart speaker that can start a timer with a set duration. And after it's extracted your intent and the duration, it will just start the timer with that duration so that the alarm goes off at the end of 10 minutes. Today's smart speakers have many functions. Other than the 2 we've talked about of telling jokes and setting a timer, here are some other functions that many smart speakers today can execute. And the key steps of executing these commands are trigger word or wake word detection, speech recognition to transcribe the text of a command, intent recognition to figure out which of these functions or which of these commands you want to execute, and then a specialized program to execute whichever command you uttered. One of the challenges of the smart speaker world is that if you want your smart speaker to have this many different functions, say 20 different functions, then you do need software engineering teams to write 20 specialized pieces of software. One to play music, one to set the volume, one to make calls, one to ask for the current time, one to convert units like from teaspoons to tablespoons, or to answer very simple questions, and on and on. And so it's actually quite a lot of work to write all of these specialized programs to execute all the different commands you might want to execute in step 4. And smart speakers today actually do so many things that is difficult for many users to keep straight in their heads exactly what they can and cannot do. And so many smart speaker companies have been investing a lot in user training to try to let users know what are the things that smart speakers can do. Because on one hand, they can't do everything. There are a lot of things you can't ask smart speakers to do, such as please call up my 3 friends and see when all of them are able to meet for dinner. And so it's been an ongoing process for the smart speaker companies to explain to users what they can and cannot do. Nonetheless, with what they can do, using voice to command these speakers is making life much more convenient for many people. I hope this video gave you a sense of what it takes to build a complex AI product such as a smart speaker. In order to help you better understand how these complex products work, let's go on to see a second case study of how to piece together multiple AI components to build a self-driving car. Let's go on to the next video.